All right, so let's see. I've started the recording. Let's see when the notification tells me that it's ready. We'll start. All right, so welcome to March 20th, 2023 for our meeting for the Scientific Research and Methods and Ethics course. So you'll notice that this is actually the slide here that I have on here is not the title of today's meeting, but that was because I wanted to make sure that we cover the last slide in this set a little bit more. You know, as I get older, sometimes my memory isn't so great, but I seem to recall not really feeling like we went over this well last week. So I want to make sure to cover this more in depth because just making sure we understand what good research looks like. Okay, so just kind of want to go through these bullet points before we move into the defining the problem. And if that pushes us back a little bit, that's okay. I'm not too upset about that. But I wanted to kind of make sure to cover these more clearly, okay? Because even like the first bullet point, the purpose being clearly defined, again, I feel like we didn't necessarily go through these well and in depth last week. So the purpose being clearly defined, that would include things like, yeah, make sure I'm understanding, make sure it's not included as part of another bullet point here, but yeah, that would make sure to set good boundaries for where the research, what the research is supposed to cover. Okay, so you know, the example we went over last week that I showed you guys. Did I include the link in the team? Oh, not that. Let's see. Did I include the link in the team to the paper? Let's see. I don't see it. Did I? There was the article about the mask wearing. Yeah, actually, I guess I did include it. Okay, so yeah, I did include it. Okay, good. So the reason, yes, that's right, Bodak, the mask paper. The reason why I wanted to bring that up again is because that paper kind of clearly defined what its boundaries were, and from the beginning, what they described was that they were studying specifically about how enforcing or encouraging mask wearing, how did it affect an uninfected person wearing a mask, and whether or not the mask wearing decreased the chances of them becoming infected, right? And which is good, right? Because it's like they're clearly defining, okay, we're not saying does mask wearing, and specifically related to COVID-19 too, that was the other part of the boundary they were setting up. And they weren't trying to say, okay, does mask wearing in general affect people's ability to not become infected by any virus? Like they weren't specifically, they weren't trying to make these broad conclusions. They were very clearly defining the purpose. Okay, one drawback sometimes for for people who aren't in the field of whatever is being studied can be that sometimes by clearly defining the boundary then other people who are reading our papers might draw conclusions we don't intend for them to draw. So for example, again, the person that shared that with me, the comment they made was, oh, this clearly shows that mask wearing has no effect at all on COVID-19 infections at all. And that wasn't what their boundary was. Their boundary was, does a person wearing a mask who's not infected currently, does it prevent them from becoming infected? Which pretty early on, even right after this paper, I saw it was pretty well established that what the general consensus was that mask wearing was preventing infected people from distributing the virus to others, whereas didn't really have much effect on uninfected people getting infected. And so, but that was where they clearly defined their boundaries. Again, a perhaps bad defined boundary might be something like, we want to make the world a better place. Like, well, okay, that's not exactly a boundary, right? Or we want to study why is the world a bad place? You know, just something like that, where it's just not clear, right? So we want to make sure that we are clearly defining what our purpose is, and therefore what our boundaries are. Okay, so again, their purpose in the paper I shared last week, purpose was, we want to study specifically COVID-19 infections, and we want to study how mask wearing, we're kind of controlling for other factors, like, so we're not necessarily going into the realm of social distancing and vaccinations. You know, we're not dealing with all that. We're saying, how does mask wearing specifically affect uninfected people of COVID-19 becoming infected? All right, so that's where we are. So clearly defining our purpose and therefore our boundaries is very important. Okay, let's see. Procedure used. We need to describe our procedure used in sufficient detail for reproducibility. Again, reproducibility is. I can't remember if I shared my thesis on here, my dissertation, in the class materials yet, but that is a kind of a focus of my research, was about how to enhance reproducibility. Reproducibility in science is very important. It is the ability for future researchers to be able to reproduce our results so that we can have more confidence that those results are accurate. Okay. Obviously, reproducibility not 100% guaranteed. You know, just because you do similar research same time, right? But we want, if we can reproduce results, we have more confidence that the results are accurate. Right? If, however, let's say I have a close friend who loves to eat McDonald's. Like she eats McDonald's all the time, right? She's like my wife's best friend, and anyway, if we had a research study that showed that McDonald's produced lower blood pressure, lower cholesterol if you ate McDonald's every day, you know, first we would be kind of suspect that would be the case, right? We would say, what's going on here? And then if somebody else followed up that study with a similar study that followed the same procedure, and we got different results. Okay, so maybe we got higher blood pressure, higher cholesterol, higher incidence of heart attack and heart disease. Right? We would say, okay, what happened here? Right? Why did these studies produce such different results? Right? And so what we're looking for is, we're not necessarily wanting to reproduce results for the sake of reproducing results. What we're looking for is reproducing our results and conclusions so that we can have more confidence that those results are correct. All right, we want to have some trustworthy results in our scientific process. Procedural design carefully planned. There's an old saying that if you fail to plan, you are planning to fail. And basically, what this bullet point is all about is about making sure that before we engage in whatever procedure we are going to enter in, whether it be an experimental procedure or a questionnaire-based procedure or an observation-based procedure, whatever it is, we need to plan it out well in advance. Right, so we don't need to be planning our procedure while it's going on. That's going to result in bad. It could result in non-trustworthy results. So we don't want to go there. Flaws in the procedural design reported, and effects estimated. Again, coming back to that mask paper, that was where they reported that some of the issues in their results, some of their issues in their procedure were, we relied on people to self-report, so we needed them to be accurate. And that's not saying we don't trust our participants. what that's saying is, because we relied on them, our results are only as good as their honesty. Our results are only as good as their ability to accurately report their own experiences, right? And so it's, again, not saying that the results are flawed, but what it's saying is we don't know how well we can accurately report. We don't know how well we can say these results are true. We can only say this is what we were given as data. This is what our participants gave us. All right. So if you look through some of those issues at the beginning of their paper, issues reported, I can't remember them all and I don't have it up in front of me, but those were some of the things where they're reporting their flaws and estimating the possible effects. Okay. Adequate analysis of data. So there are 3 of you on this call right now. If I were to do an observation-based research of Turkish graduate students and some aspect of that, maybe level of commitment to attending lecture, maybe, oh, we got a new 4th person just arrived, okay. Maybe full commitment to attending lecture, or participation in lecture, something like that. If I were to just use the 3 of you, or 4 of you now, if I were to use the 4 of you as my data source, that would probably not be a good estimate of all of the Turkish graduate students in the country, right? Because, yeah, no, it's okay, but yeah, it's fine. If I only used 4 of you, all from the computer engineering graduate program, it would not be a good representation of all of Turkish graduate students, right? What I need is a good sampling of different fields. I need a lot more than 4. Now, obviously, because of the limitations of our ability to do things, we're not going to have to feel like we need to get all graduate students in the entire country involved in our study, because that would be way too much and quite difficult to do. But clearly, we need to have enough participation and enough sampling to make sure that we have a good sample group, right? The validity and reliability of the data checked carefully. Again, we just want to make sure that whatever we do, we are being responsible in our data. We want to have different researchers be involved. One researcher involved in collecting all of the data, and that person being the only one in charge of making sure the data matches or is correct and valid, can be a problem, because the truth is there are lots of we're all human, right? And we can make mistakes. On the really bad side of things, we can make intentional mistakes, right? Where maybe we are trying to justify a certain point. We're finding that the data we're getting isn't quite what we want it to be, right? And that can be something that can happen on occasion. So that's why we need someone else involved, and hopefully not someone else that has necessarily the same potential temptation to manipulate the data unethically, right? We need to make sure that we have reliable data, and we need to have multiple people involved in collecting and compiling the data. Justifiable conclusions, again, making sure that we have a reason to state the conclusions that we're making. Okay, coming back to that mask paper, they don't make any conclusions about how mask wearing affects uninfected people's ability to become infected or not, because that wasn't what they were studying. And because they did not they didn't make any conclusions based on that. In fact, if I remember correctly, they even state in the paper, we're not making conclusions about this, and it would be premature to make any conclusions about that based upon our paper, right? And so to make sure that the conclusions we make are based on the data, based on a good analysis of the data, and that they don't make other conclusions that aren't justified by the data itself, right? By the data and the analysis of the data itself. Okay. This is it can be a sad one. It can be a good one. It's kind of up to you. But the idea that reputation and integrity can produce higher confidence. So the more that we are known to be to follow these points here, that we are honest in our data collection, that we are hardworking and not hardworking, but more like purposeful and intentional about our data collection and our data analysis, that we justify our conclusions based on the data as it exists, right? And as it was correctly analyzed. The more that we're known for that, the more in the future we will have higher confidence. People have higher confidence in our ability to continue with that, right? Continue with that mode. And so therefore, our future results will also be trusted based upon our previous results. And in fact, one story comes to mind from about 20 years ago, where there was a researcher that basically had produced a paper, had gotten it published in a journal. It was very cutting edge. Within a few months or so, I think, it was found that during their calculation, basically they had done a very simple error that many of you, I know I have done this before in my own studies, but basically they had accidentally switched a negative sign instead of a negative. It should have been a positive one, but they had recorded it as a negative one instead, and their results were all basically tainted by this simple switching of a negative sign on a value. And as a result, when they discovered this, they self-reported. Okay, great. They self-reported that their results were tainted. They had their paper retracted, their original paper retracted. The new result actually ended up in less certainty as far as a result and a conclusion could be found. It was basically one of those with the negative sign, with the negative value, or whichever one it was. I'll have to look it up. But with the negative value, the results were very clear and the conclusions were very clear about what could be inferred from that. Without it, it was more kind of like, oh, well, we don't have clear results and we don't really know how this works out. But one of the things that came about because of that was actually those researchers in that lab, their reputation took a big hit because of this one paper, this one negative sign. And so being very careful in our analysis and being very careful in our obtaining results and conclusions is very important because, again, I need to go find this paper because it was such an important part of my own research and my own understanding that I'm gonna have to find it so that you guys can see it. All right, so I'll make myself a note about that. All right, question. So you guys watch Popeye in Turkish? I did not know that you guys had Popeye over here. Wow. Yeah, I watched it as a child as well, and interesting. So he ate spinach here too. And maybe I should show it to my children so that they'll start eating spinach. None of them like it. I like it. They don't. None of them like it. All right. So let's do this. Are there any comments about what we've discussed here before we move over to the defining the problem slides? Okay, let's do this. Let's move over to the defining the problem slides. Okay. So you guys should be seeing this now. Okay. All right, so now I want to make sure, I think I've mentioned this before, but I want to make sure that we are clear that problem does not have to be a bad thing. In research, a problem is some difficulty which we experience in either the theoretical or practical situation, and we want to obtain a solution. Now, again, one of the things we talked about, I think last week or maybe 2 weeks ago, is that it does not have to be, it doesn't have to involve a solution. It could be just we want to understand the universe. And astronomers, I think I used astronomers as an example of people who research things that sometimes we don't necessarily need to find a solution for. We're not trying to find a solution for how fast the Earth revolves around the sun, right? That's not something we're trying to find a solution to, because it doesn't need a solution. We're just wanting to discover how planets and stars and how they interact. We just want to understand more about the universe. So in a sense, the problem in those situations could be simply the problem is we have a lack of understanding and we want to have more understanding about something. Okay, so we need to oftentimes, if we are searching for a solution to a problem, a what we would traditionally call a problem, something that needs a solution, then we may need at least 2 courses of action, right? At least 2 possible outcomes. Now, 1 course of action could be do nothing, right? So we're going to propose a solution. We're going to propose possibly 2 or more solutions, but one of those course of actions could be do nothing. So if you think about a medicine-based study, where we are trying to study the effects of a new pill or a new injection, like a vaccine or something like that. You guys probably know about I'm assuming you guys know about the placebo, right? So the placebo basically is kind of a do nothing solution, right? So we're trying to study, okay, go back to the pandemic. We're trying to study vaccines. Well, during the clinical trials, vaccines, I think it's like a water solution or a sugar water solution. There's some type of special chemical that they inject that doesn't cause any problems. It's saline, that's right. Not sugar. That's something else. But they inject that and it does nothing, right? And so basically what they're studying, and I'm not a immunologist or virologist or anything like that, so I don't know much about these things, but I would think that what they're studying, what they follow up with is, okay, we injected some population with the actual vaccine we're studying. We injected some population with the saline solution, right? And we're wanting to see how well does those injected with the actual vaccine we're testing, how well do they respond, whether it be generally it's how well do they respond in terms of not becoming infected themselves, or as you probably read about it, a lot of things, a lot of the results in the once the vaccine was actually being administered, that they were finding was maybe some people were still getting infected with the virus, but they were having a reduced experience. They were having a less traumatic experience with the illness, right? And so, but one of the things they're studying when they're doing this was, okay, those that got the placebo, did they have an equal experience in terms of getting infected? Because if they're having the same experience in terms of infection rate as the vaccinated population, then the vaccinated population, they're not having any positive impact, right? If in some cases we may end up in a situation where the placebo group is actually having a better outcome than the vaccinated population. So, you know, and in that case, we just want to scrap that vaccine option, right? Stuff like that. So again, one course of action could be do nothing. The other course of action could be administer the vaccine or do whatever it is, whatever solution we're proposing, right? Some possible outcomes. What is the preferred outcome? The do nothing outcome, we would assume that the infection rate would continue with the rate that we've been experiencing. The possible outcome of vaccinating someone is, again, they get infected at a lesser rate. The case, if they do get infected, the case that they experience is a milder case, something like that. Okay. The course of action must provide a unique probability of achieving the objective. So what is the probability that doing nothing produces reduced cases? What's the probability that giving a vaccine produces reduced cases or milder cases? Okay. So this is how we're going to define our problem, but how do we decide on what a problem should be? Like, what should we study? Because this is, I get this a lot with undergraduate students wanting to decide on a project for their senior design project. You know, what should I do? What should I do? Also, graduate students also are, many of you, I don't know how many of you already have your thesis topic already decided upon, but many of you, I would imagine, do not. If you're a first year student, if you're a first year graduate student in our program. But some of the general guidelines is you don't want to do something that's done overly done, right? It's kind of, I'm gonna go find a comic that's best for you. That I think is related to this. So the idea is that if many people have already done the topic, then you may be just adding a drop to the ocean that exists of this research, and it may be difficult to find something that is what we would call novel enough, new enough to be able to contribute meaningfully to the research. From a selfish for us standpoint, if you don't have something new or novel, it'll be hard to get published, it'll be hard to get funding, it'll be hard to get things that you'll need to get done in order to continue being able to produce research. Okay, so you don't want to necessarily do something that's had a lot of research done on it already. A controversial topic, you should be cautious about considering a topic that's controversial. This is not to say you shouldn't do controversial topics. It's just a matter of it can be difficult to get good research in a controversial topic because people may have strong emotions about these things, and which again could end up having a lot. You could end up spending a lot of time defending a position or defending your results in situations where it's how can I word this? In situations where you'd prefer to be working on and making progress. But you guys probably understand the reasons why controversial topics can be a thing to be cautious about. Okay. Narrow or vague problems. So vague problems, we want to come up with a solution for world hunger. Right. That's kind of vague. You're not really defining the boundaries well, right? We want to propose a solution to that would get rid of COVID-19 from the earth, right? Well, how? I mean, there's lots of, specifically you need to propose specifically about something about the nature of the pandemic that you're trying to study. Right? You need to choose something which can be relatively easily engaged, which means something that you know something about already. Okay, so like for me, maybe I might want to research something in the realm of, let's see, construction or architecture. I might look at buildings, okay, in light of the recent earthquake, right? I might want to consider how buildings could be built better to withstand earthquakes. But that's not my field at all. I've never studied this before. It might be something easy. It might be something nice for me to research as a hobby, but as far as something that I would study, study well and focused and write papers about, it's probably not something I'm going to do for that. But no, I shouldn't say probably. It won't be something I would do for that because it's not my field. Right? It's not something I've studied before. I've not entered into that before. So for me to get up to the place where I would be able to have confidence that I would understand that topic would take a long time for me to get to that place. Right? And so you don't want to go into a field that is something that is not close to what you've already known and what you've already studied. Well, let me ask this, because oftentimes our graduate students don't always come from computer engineering backgrounds. So what is, for each of you guys, so each of you on this call, Urjan, Barak, and Shirin. So what is your background? Do you have a computer engineering background, or are you from some other background? And you can either just say it or type into the chat.
I personally have a computer engineering background, sir. You're actually one of my professors from the year you left your previous place of residence, right?
Oh yeah, okay. All right, so Shirin, you're from electrical and electronics. That's actually my undergraduate. All right, and a couple of you guys from mechatronics also, and so we have one from computer engineering, right? And so all of you are actually you're close to our field, so there wouldn't be a huge shift over to a topic, but like one of my graduate students is that I'm advising. His undergraduate, his licence was from physics, right? And so he actually had to take a lot of what we call the preparatory courses. It's kind of like a Hausarlook for computer engineering, where he had to take like computer science 101, right, with us. And so even though he was a graduate student, he was taking the 101 course because he had very little background in writing computer programs. Now his science background helped him, but and so what I oftentimes suggest for students in those situations is your research topic definitely needs to be within the field that you are currently in, the computer engineering field, but look for something that's close to what you already know also, right? And so which kind of comes into this whole time commitment and cost and availability and qualifications, right, as far as some of that's concerned, because if you choose a topic that's so different from what you already understand and already know, so for me, like this, if I were to say, I really want to study this building construction topic, right? Well, that's a time commitment I'm going to have to make to study the background before I can get up to the level of expert to be able to really study it in depth, right? So there's a time commitment I've got to factor in. Cost, am I going to have to pay for courses or other things to be able to have access to the training and knowledge to be able to get up to there, right? Cost in research even related to our field may be a factor as well, because do you need access to a server farm, or do you need access to a parallel computing why am I blanking on the word for it? But they have parallel processing machines that are like basically where you can rent out time on them, right? And is it going to cost you? Do you need to buy some equipment? Do you need to buy some computers or servers to be able to engage in the research that you're wanting to do? Are you going to have to buy software, simulation software, or something like that to be able to run the simulations that you're trying to run? Okay. Availability, what is do you have access to the things that you need to have access to? So and also understanding that you can be limited by the place that you are geographically, right? One thing that I often can surprise people is that so my home country, America, actually, I believe we are, I don't even know if we're in the top 10. We may be in the top 10, but in terms of internet speed, we actually have slow internet compared to other places in the world, which oftentimes surprises people. But my understanding is that a big part of why internet speed is slow in America is that every internet provider, every internet service provider has to provide their own physical material. So in terms of like fiber optics, you have to provide your own fiber optic lines and things like that. Whereas in some other countries, there's a central, sometimes government-based company that provides the things like the lines and things like that, and the companies, the internet service providers, connect into that system. And so in those places, the internet speed is able to be faster because not every company is providing their own stuff, right? And so availability of resources needs to be considered. Cost, availability, is just CERN, right? The collider, right? That not everyone gets access to that, right? You have to wait your turn, and you have to. My understanding is, and again, I've never used it, so I don't know about it, but my understanding is that it can be a long wait, and you have to be really ready. Like whenever your turn comes and you have access to the collider, like you have to be able to. You have to be ready because you only have it for a limited time too, and so you have to be ready to study whatever it is that you're wanting to study there. Yeah. And then researcher qualifications comes back to what I was talking about before about knowing your limitations. What is your field, and are you sufficiently qualified to be able to study the things that you're doing? And then before you engage in a main research, do some preliminary background research. Now this preliminary study can end up becoming the backbone, the background for your literature review, right? So one of the things that every study should include is a literature review. Again, I think I talked about this last week, to show that you've done a good amount of homework to see what amount of homework to know that you are thoroughly understanding the field and the problem that you're studying. Okay. All right. Quote by Charles Kettering: "Problem well stated is a problem half solved." Again, okay, I'm not necessarily going to go into this in too much depth because I've already talked about this some. throughout last week and this week already. The idea that making sure that we have a good worded problem, right? Making sure that we really have a good definition of what it is that we are trying to solve, right? We don't want to have a lot of ambiguity. So if I were to say, okay, let's again come back to one that I've said before which says my problem, the solution I want to offer is I want to make the world a better place. Okay. I want to make the world a better place. I'll type it in there. That's a good solution, right? That's a good thing, right? Make the world a better place. What are some problems with this? What is this a well-stated problem or a well-stated solution? How about maybe the problem is the world is a bad place. Let's not say it's a bad place. Let's say the world could be better. Okay. So our solution is make the world a better place. What are some problems with this? Yeah, it's unclear. Like, well, what's not clear? What's not clear? I agree. It is unclear. What's ambiguous? Yeah, for who, right? Because are we going to make the world a better place for humans? Are we going to make the world a better place for animals? Are we going to make the world a better place for plants? All right. Well, I want to make the world a better place for all of this, for everybody.
How better would you want the world to be? Any amount of efforts could basically be a solution, right?
You mean like how much better? Like is there's a metric about like what percentage of better?
Yes, basically.
Yeah. Yeah, it should end says here, what is the problem? You know, why the world's not gonna, because even like saying the world could be better, in what regards? Right? I mean, are we talking about in terms of the number of people who don't have access to necessities like housing and clothing and food, right? Are we talking about climate change? Right? Are we talking about back when I was younger? We don't hear as much about it anymore, but the ozone layer, the hole in the ozone layer, right? All of these things could be related. Are we talking about how many conflicts there are and war and things like that? Right? What do we mean by better? Right? Or what do we mean by bad? Or what do we mean by good? Like those things are not clear. They're not clearly defined, right? So we might say a better problem and a better option for a solution could be something like, well, we'd have to study and find out, okay, what percentage of the world's population, and maybe not even the world, we might just focus in on a particular region or a country, right? We might say, okay, what percentage of the Turkish population, of the population living in Turkey, does not have adequate food on a daily basis? Okay, and let's research that and figure out, okay, what percentage, and then we're going to propose a solution. Now the solution won't be, I would imagine, couldn't be everyone gets enough food. Like the results of our study. Now, if that happens, that'd be great. But we really need something that's actually we're talking about proposing a solution now. And we'll get to that. But the idea would be there are million problems. Yeah, exactly. Which one do you choose to solve? So that's what I'm saying, like this food aspect, right? And so you might say, okay, what we'd like to do is propose a solution that would result in a reduction of half of the people that currently are without food will no longer be without food, or something like that, right? We need something that's measurable, right? Something that's that we can say, what is the result and what is does it fit within our metric, right? Okay. We're getting close to out of time. Let's see. Oh, yes, okay. You know what? Let's do this. There are 3 more slides, but I would like to discuss them more in depth, but we've run into our break time. So what I will do is we'll pick up here next week for continuing our problem discussion, and maybe do like we did this week, have some discussion on this and then move into the next topic as well. Okay. Are there any other comments or questions before I stop the recording and we can have a 10-minute break? Nope. All right. So what we'll do is, again, we'll have a break time, then we'll come back after that. Again, I shared a couple of links for you guys to look over. I shared them this morning for the topic that we'll discuss during the second hour. All right. See you guys in 10 minutes.